Okay, it's time to have a little more fun completing the square of quadratics, and we're going to use that method in this case to solve quadratic equations. So before we get into some examples, just want to just talk a little bit about a couple of options when you've got. I'll just give you a simple sort of x squared minus 9 equals 0, because there's a couple of options here, and I know we're dealing with them in different ways. I don't want to confuse you, but I want to show you. It might just clear things up in terms of which way do we go when we're solving equations. Okay, so when we've got something like this, x squared minus 9 equals 0, we've got two options. Option 1 is that we treat it like a difference of two squares. So we go x squared minus 3 squared equals 0, if you know what I mean. So therefore we factorize it to x plus 3, x minus, hopefully you're getting used to that kind of scenario, difference of two squares. Right, and then we get a solution 3 or minus 3, and we can write 3 or minus 3 as just like that, plus or minus 3. Okay, that's option 1. Option 2 is to get, when you've got x squared and a number, so there's no x term, x squared equals 9, put the 9 over the other side of the equation. So you've just got x squared equals 9. Then take the square root of both sides, so x equals, but when you take the square root of a number, you've got to consider the plus and the minus version. So x equals plus or minus root 9, and root 9 is 3, so that's just plus or minus 3. Okay, which do you prefer? They're both the same. You need to be able to do this stuff, don't you? But when you're solving an equation, you might prefer to go down this route. So we might refer back to that in a moment when we're looking at some examples. So let's look at solving firstly by completing the square. So solve by, I'm going to just write CTS, completing the square. Okay. All right, A, x squared minus 4x, x squared minus 4x plus 2 equals 0. Okay, so what I'm going to suggest here is, this is what we do. I think this is the easiest way of solving, and it's going to go a lot along the lines of this one here, this option 2 a little bit more. So first thing I'm going to get you to do is I'm going to get you to clear this 2 over the other side of the equation. So the plus 2, we're going to bounce him over the other side of the equation to become minus 2. So on the left hand side we haven't got any more clay, we've just got x squared minus 4x. Now the next step, really important step, is to complete the square. We've been told to solve by completing the square, so we can't just go any old how. As it happens, this is not one you could factorize, multiplies to 2 adds to minus 4, but okay, let's now complete the square. So this number here needs to be, remember, the square of half this number. Half of that number is minus 2. Square it, it's 4. So I need a plus 4 there for this to be a perfect square. But you know with equations, you do something to one side, you've got to do it to the other. Okay, so we've done two things. We've removed the 2 to the other side of the equation, became minus 2. Now I've added 4 to create the perfect square here. I've got to do the same to the other side of the equation. All good so far? So what I've got now is x squared minus 4x plus 4 equaling 2. Okay, now this left-hand side is a perfect square. What is it? It's x plus a half that, or in this case minus 2. A half of the minus 4 that we squared to get that goes in there, doesn't it? So this is x minus 2 squared, and this is 2. So right now I'm going to talk about option 2, where I've got it just as I've got something squared equals 2. I'm going to get rid of the squared by taking the square root of both sides. So take the square root of this side, the square goes. You just got x minus 2. So take the square root of this side, plus or minus the square root of 2. So now I've just got to add 2, and I've got my solution. 2 plus or minus the square root of 2. What I did that last step was take that minus 2 across, became plus 2. So there is my solution. 2 plus or minus, my solutions actually, 2 plus root 2, 2 minus root 2. Root 2 being about 1.7, so the solutions in decimals were about 3.7 and about 0.3. Okay, obviously irrational, sturdy answers. Okay, have a little think about that. You might need to pause, go over it again. You might just want to go on with the next example. And if you're good enough, if you think you know what the technique should be now based on that first example, then have a go at it yourself. If you want to have a look at one more, do so. Maybe do the third one yourself. Okay, so this one, what do we do first? X squared plus 6x. We're going to clear the minus 11, aren't we, and put him over there as a positive 11. The next, so we've created space here to complete the square. This number is the square of half this number. So half that number is 3, square at 9, so plus 9 to both sides. What have I got now? On this left side, I've got x plus 3 all squared. On the right side, I've got 20. I'm taking one step less on this occasion, aren't I? X plus 3, taking the square root of both sides, plus or minus the square root of 20. Well, we can do better than that, can't we? We've done surds. We know that the square root of 20 can be improved upon. Right, square root of 20 is the square root of 4 times the square root of 5. We've got to always use the maths that we've learnt already to improve the standard of our work. So 2 root 5, remember, is the same as that. So I'm going to rewrite this as x plus 3 is equal to plus or minus 2 root 5. I only got one thing to do, and that is to remove this plus 3 from the left-hand side, so it becomes minus 3 over here, plus or minus 2 root 5. Minus 3 plus or minus 2 root 5. Okay, I would like you to have a go at C, please, without me talking about it first. So x squared minus 3x plus 1. Oh, it's a nasty one. It's a nasty one. It's got a minus 3 there. So if you've left it up to this point, okay, this is a tough one for you to take on, but pause and have a go at it. Okay, so my work here is going to be x squared minus 3x, same as minus 1 goes over there. I'm going to, halve it, which is 3 over 2, and then square it, which is 9 over 4, isn't it? So plus 9 over 4, I'm going to plus 9 over 4 here so that my equation stays balanced. Now the left-hand side, what does the left-hand side look like? X minus 3 over 2 squared. All right, now this over here becomes 5 over 4. So x minus 3 over 2, that's a half of that. It goes in there. 5 over 4 is the result of what I did there. Was take that as minus 4 over 4 and added 9 over 4. That's how we deal with fractions. Minus 4 plus 9 is 5. Okay, now I'm going to take the square root of both sides. Square root of both sides. X minus 3 over 2 is equal to plus or minus the square root of 5 over 4. But we're going to improve on that, just like we improved on the root 20 up there. Root 5 over 4 is equal to root 5 over root 4. And you should see that that improves to root 5 over 2. That's what root 4 is, it's 2. Okay, so let's rewrite this as x minus 3 over 2 equals plus or minus the square root of 5 over 2. Okay, that's root 5 over 4 simplifies to that. Last step is to take the minus 3 over 2, make it a plus 3 over 2 over here. So 3 over 2 plus or minus the square root of 5 over 2. We've got common denominators, we can put them together, so it'll read like this: 3 plus or minus the square root of 5 all over 2. That's the magic gold standard answer right there. Okay, we're good now. I think we can take on exercise 5H when I next see you in class. Cheers.